Welcome to EDU World Space.
A planet is orbiting everyone's favorite star, HD 68988, and given the distance from the planet to the star and the orbital period of the planet, we're asked to find the mass of the star. So, um, first off, I want to convert a lot of these quantities they give us. So they give us the distance as 10.5 million kilometers. So 10.5 then times 10 to the 6 kilometers, but let's just make this meters right away. So plus 3 more, so times 10 to the ninth meters. And we're given that the period is 6.3 days, and we'll want that in seconds. And so doing that, we should find that it's 5.44 times 10 to the fifth seconds. So now we just don't have to worry about those later on. So we want to find the mass of the star. So this is circular orbit. So one of our go-to equations for that is that the velocity of the planet orbiting will be the square root of g times the mass of the star divided by the orbital distance. So let's solve for the mass of the star here, and then we'll see what else we need. So we square both sides of the equation. V squared equals gm over r. And then we get m by itself as v squared r over g. So we know r, but we don't know v. But given that they've given us r and the period, we should be able to find it. So we'll come over here, and we know that the period is just the circumference, or the total distance of the orbit, divided by the velocity of orbit. So let's solve for the velocity here. So that's just going to be 2 pi r over the period. And so now these are things that we all know. We know the radius of the orbit, and we know what the period is. So I'm just going to plug this quantity directly into our equation over here. So doing that, we have 2 pi r over t, and that whole thing is squared, and then times r over g. Oh, and those are the same r. So simplifying that, we should get 4 pi squared times r cubed, and divided by tg. So r we have up here, remember we're using these that we've converted to meters and then converted the period to seconds. And so when we evaluate that, we should get a mass of 2.30 times 10 to the 30th kilograms. And then we're asked to convert that into solar masses relative to the mass of the sun, and helpfully we're advised to look that up in Appendix F. And so in doing so, we should be able to find out pretty easily that this will be 1.2 times the mass of the sun, so a little bit heavier than the sun.